hour, there's no construction, no accident, but boom, traffic jam, seemingly out of nowhere. Why? Researchers call this a phantom traffic jam, but it's not supernatural. It's mostly caused by humans.
These are jams that occur even without the presence of an accident, without the presence of, say, on-ramp, so no seeming cause.
Here's how they happen.
When vehicles are bunched up too closely together, then a small sort of tap on the brake pedal of one car at any point in time could cause a driver behind it to also tap on its brake pedal a little bit.
This continues down the line of cars, each one pressing the brakes just a little more.
Until there's a car that actually has to come to a complete stop. And then all the vehicles behind it also have to stop. And then we have this formation of a traffic jam that may have just started from this little tap on the brake pedal.
This is different than just regular congestion, although they do happen during heavy traffic. These phantom traffic jams are actually super energy inefficient and more dangerous than typical congestion.
Phantom jams are bad because they force drivers to drive, stop, and that's where all the energy inefficiency comes, because every time you stop, you have to reaccelerate, and that's how you burn fuel.
When a vehicle is coasting or decelerating, it's emitting much less than if it's sort of, blasting the engine.
But there's a secondary impact of phantom jams, and that's the fact that they increase the likelihood of accidents.
So if phantom traffic jams are mostly created by humans, could the solution be non-human drivers? No, not that kind. This kind, self-driving cars, also known as automated vehicles. Could they actually eliminate some traffic jams and make the roads safer?
On average, if a driver stops and drives and stops and drives, the travel time would have been exactly the same if the person had driven at the average speed the whole time. And so that's one of the things that traffic flow smoothing is trying to achieve.
In the case of automated vehicles, I would say we actually have this additional opportunity that while we're helping passengers get to their destination, we can do a few other things along the way. We can help smooth out traffic, we can help to make the roadways safer, we can help to make the roadways more energy efficient, reduce air pollution.
Experts say that having all autonomous cars on the road would be the best way to keep traffic moving smoothly. But can self-driving cars prevent phantom traffic jams if they're sharing the road with humans?
So in the case of phantom jams, the intention of the human is usually to catch up with the car in the front, which is something relatively easy to model for a machine, and which is also something relatively easy for a machine to counteract.
So to counteract the start of a phantom jam, the autonomous cars would figure out the best following distance and speed to avoid making any instability in traffic worse. But on the road, humans aren't always predictable, or let's be honest, paying attention. At least not compared to other autonomous cars.
Humans are complex, and also the variety of goals they have when they go on the freeway is quite wide. In some ways, automation is easier when the human is taken out of the equation.
Would a robot slow down to look at an accident on the highway? Probably not. And a human's main goal probably isn't to prevent a phantom traffic jam. Even if that human is a professor who studies the dynamics of transportation systems.
I'm definitely a person who, if I see a lane that's open, I go there and I sort of move in and out of sort of traffic. And so that can actually be optimal sometimes.
Though the definition of optimal may vary between drivers and between human and machine.
There's a notion of sort of being socially optimal versus, optimal. This is sort of the benefit, I think, of autonomous vehicles is that if you can look a little bit beyond yourself, cars are doing things that are sort of optimal for the sort of global system as opposed to sort of a local system.
So for researchers like Kathy Wu, the goal is for the automated cars to be safer, better drivers than humans, not replicate human driving.
If we want to do better, we as humans should not be telling the automated systems what to do, or it will just, reflect back at all of our imperfections. We can directly specify this objective. And what was remarkable for us to find is that the system could actually identify strategies that were effective in achieving some of these objectives that are different than how humans drive.
Researchers are still testing traffic control technology in autonomous cars. And there are still a number of barriers to accessing these kinds of vehicles.
The aspect of cost and access is something that concerns me. I don't have an answer. I think that what we'll see early on, at least, is automated technologies in more niche scenarios. So we'll see them probably in automated trucking or freight, in low speed environments like college campuses, in fair weather locations like Arizona, like California, in shuttle buses on fixed routes. And so in these restricted domains, this is still rather narrow, but this I think will allow the designers and engineers to test out the technology, adjust for risk, gradually build consumer acceptance and trust.
One of the things I like to tell people about autonomous vehicles is that it's perfect if we can get it right, but we should also understand the things that sort of arise that we as a society need to sort of come to before we sort of release them all on the road.